Hello, bedtime thinkers, and welcome to the Bedtime Discoveries. I am so glad you are here tonight. This is a space for rest, for gentle wonder, and for letting your mind drift calmly through the universe. Tonight, we will quietly journey into one of the most mysterious and silent places in the cosmos. Black holes, the quiet giants, sometimes called the silent monsters of space. They are not monsters in the way we imagine in stories, but rather powerful, invisible wells of gravity that shape galaxies, bend light, and challenge our deepest understanding of physics. Before we begin our journey, I'd love to know where you are listening from. Would you kindly write in the comments your current location and the time where you are? It's always beautiful to see how people from all around the world drift together into sleep beneath the same stars. And if you find peace here, please remember to gently press the like button and subscribe to the Bedtime Discoveries. It helps this little community of dreamers grow and allows me to bring you more calming explorations like this one. Black holes, silent, invisible, and mysterious. They are among the most fascinating creations of the universe, and yet they are not things we can see with our eyes or even touch with our hands. A black hole is not a solid object like a planet, not a ball of gas like a star. It is a region of space where gravity becomes so powerful that nothing, not even light, can escape from it. Imagine for a moment the force of gravity here on Earth. It is what pulls an apple down when it falls from a tree. It is what keeps our feet gently resting on the ground. Even the moon, circling above us, is held in its endless orbit because of gravity's quiet pull. Now, imagine gravity growing stronger and stronger, more powerful than anything we know, until it becomes so intense that escape is impossible. That is what defines a black hole, a region where space itself is curved inward, where time flows differently, and where the normal rules of the universe seem to break apart. The term black hole was first made popular in the late 1960s, but the idea is far older. Back in the late 1700s, even before Einstein's theory of relativity, scientists like Jean-Michel and Pierre-Simon Laplace wondered if a star could become so massive, so dense, that its gravity would trap light. They called such objects dark stars hidden from sight. Centuries later, Einstein's equations of general relativity gave us a deeper understanding and showed that such things not only could exist, but must exist. But what truly makes them so haunting is that we cannot see them directly. They do not shine. They do not reflect. They are dark, silent. To us, they are invisible wells, hidden against a starry backdrop, revealed only by how they affect the world around them. They are, in every sense, cosmic shadows. Think of standing at the edge of a canyon at night. You may not see the canyon's depths directly, but you feel its presence. The air moves differently. Your voice echoes back with a hollow resonance. And if you drop a stone, it disappears into the unseen depth below. In the same way, a black hole is invisible, but its pull is undeniable. Black holes are not rare. Astronomers believe there may be millions of them in our galaxy alone, some quietly drifting, some hidden in binary star systems, some at the hearts of galaxies where they become truly enormous. Yet, even with their abundance, they remain mysterious because their very nature hides them from our gaze. To understand a black hole more deeply, let us imagine shrinking something we know. Take our Earth. If you were to compress the entire mass of the Earth into a sphere about the size of a marble, gravity would grow so intense that even light would not escape. That marble-sized Earth would become a black hole. Now imagine our sun. If it were to collapse into a black hole, all its matter would be compressed into a tiny sphere, just a few kilometers wide. The sun, which lights our skies and warms our world, will become an invisible point of darkness with gravity so powerful that anything crossing its boundary will be lost forever. And yet, if the sun were replaced with a black hole of the same mass, Earth would continue to orbit it just as before. We would not be pulled inward. The only change would be the loss of sunlight. This is because a black hole does not suck in everything around it like a cosmic vacuum. It obeys the same laws of gravity, just with far greater intensity, packed into a much smaller region of space. A black hole is not a physical object, but a region of space. At its center lies the singularity, a place where our understanding of physics breaks down. Around it lies the event horizon, the boundary beyond which escape is impossible. Together, these two features define the black hole, the silent heart and the invisible edge. But how do we know they exist if we cannot see them? We look for clues the way a detective follows hidden footprints. Astronomers observe the stars, and sometimes they find stars circling an unseen companion. Something massive must be there, and yet no light shines from it. By studying their movements, we realize the invisible companion is a black hole. The most famous example of this is in the center of our own Milky Way. There, stars orbit something unseen with incredible speed. Only a supermassive black hole, millions of times heavier than our sun, could explain their dance. This hidden giant is known as Sagittarius A*, a quiet monster resting at the heart of our galaxy. So what is a black hole? It is gravity made pure, a cosmic trap where space, time, and light are drawn inward. It is not so much a thing, but a place where the known rules of reality give way to something stranger. As we think about black holes, it is important to remember that they are not threats to us here on Earth. The nearest known black hole is thousands of light years away, far, far from our quiet corner of the galaxy. Instead, they are mysteries to be studied, wonders to be pondered, and reminders of how strange and vast the universe truly is. Sometimes in the quiet of night, we might feel small beneath the stars. But black holes remind us that even the smallest things, the collapsing star, a shrinking sphere of matter, can create forces beyond imagination. They show us that the universe is not only filled with light, but also with shadows, silence, and unseen depths. And in those shadows lies beauty. Black holes challenge us to think about space and time in new ways. They remind us that there are places where our equations fail, where our understanding falters. And yet, instead of frightening us, this mystery can be soothing, because it tells us that the universe still holds secrets, that discovery is endless, and that wonder will never run out. In the end, when we whisper, "What is a black hole?" we are really asking, what is the universe capable of creating? And the answer is both simple and profound. A black hole is the universe's way of bending reality into something both silent and magnificent. So, let your thoughts drift there tonight, into the quiet darkness where light cannot escape, where stars fall silent and space curves inward. There, in the hush of the cosmos, lies the black hole, a reminder that even in the darkest places, there is wonder. Every black hole begins its story with a star. Not every star, of course. Only the most massive ones, stars far heavier than our sun. To understand how a black hole is born, we first need to understand how stars live and how they die. A star is not just a ball of fire, as it may look to us from Earth. It is a delicate balance between two great forces. On one side, gravity, pulling inward, always trying to make the star collapse upon itself. And on the other side, the star's own energy pushing outward as it burns hydrogen into helium deep in its core. This nuclear fusion is the heart of the star's life. It produces light, warmth, and the delicate balance that keeps the star stable. Imagine it like a candle flame. The wax fuels the fire, and as long as the wax is present, the flame shines steadily. When the wax is gone, the flame sputters, flickers, and finally fades. A star's life is similar. As long as there's fuel to burn, it shines, but when the fuel runs out, its fate changes. For stars like our sun, the end is gentle. They swell into red giants, shed their outer layers, and leave behind a white dwarf, a quiet, cooling ember of starlight. But for stars far more massive, 8, 10, or even 20 times heavier than the sun, the ending is far more dramatic. When their fuel is gone, gravity takes over completely, crushing the star's core inward. This collapse is violent, sudden, unstoppable. The outer layers of the star are blown apart in a brilliant explosion known as a supernova. For a brief moment, the dying star outshines entire galaxies, sending ripples of light across the cosmos. But deep inside, the collapsed core grows denser and denser still until it forms a black hole, a region so small, yet so heavy, that nothing can escape its gravity. So, in the grand story of the cosmos, black holes are not separate from stars. They're the final chapters of the most massive stars' lives. Silent remnants, born from explosions that briefly light the universe before collapsing into quiet darkness. Let us imagine the collapse more closely. A massive star, nearing the end of its life, has burned hydrogen, then helium, then heavier elements, building layer upon layer inside. At its core, iron begins to form. But iron cannot be burned to release energy. It is a limit, the dead weight of the star. When iron fills the core, fusion stops, the outward push of energy ceases, and gravity wins. The star's heart collapses in a fraction of a second. Atoms themselves are crushed, electrons and protons forced together into neutrons. If the star is somewhat less massive, this crushing halts, leaving behind a neutron star, a city-sized sphere of matter so dense that a teaspoon will weigh billions of tons. But if the star is heavier still, even neutrons cannot resist the pull. And so, collapse continues, unstoppable, until a star vanishes into itself. What remains is not matter as we know it, but black hole. To picture this, imagine crumpling a sheet of paper. At first, it resists, folding in large creases. But as you keep pressing, it becomes smaller, tighter, denser, until it's just a tiny ball, impossible to flatten further. Now imagine that same process happening not with paper, but with an entire star, millions of kilometers wide, squeezed until it fits into a sphere no bigger than a city, or smaller still. That is the birth of a black hole. And though the black hole is invisible, the supernova that births it is one of the brightest events in the universe. Astronomers can watch these cosmic fireworks, and sometimes, hidden in the fading glow, they find the footprints of a newborn black hole. The star's light may fade, but the black hole remains silent, unseen, a child of collapse. It is almost poetic that something so invisible, so dark, is born from something so brilliant, so dazzling. The brightest death gives birth to the darkest life. While the collapse of massive stars is the most common way black holes are born, it is not the only way. There are other, quieter paths. Some black holes may form when smaller black holes merge. Two stars collapse into neutron stars. The neutron stars collide, and the crash may form a black hole. Or two smaller black holes, circling each other for millions of years, may finally spiral together. becoming one larger black hole. This is a cosmic dance, invisible to the eye, but not to the universe. In 2015, for the very first time, scientists detected the ripples in space-time caused by such a merger. These ripples, called gravitational waves, confirmed Einstein's predictions from a century earlier. It was the universe itself whispering to us, telling us that black holes had collided far away and that their union had sent tremors across the fabric of space. There are also theories that, in the very earliest moments of the universe, tiny black holes may have formed. As matter rushed outward in the Big Bang, small fluctuations in density may have caused pockets of collapse, leaving behind what scientists call primordial black holes. These would be tiny, perhaps smaller than mountains, or even smaller than atoms. Though we have yet to detect them, the idea lingers, like a quiet possibility waiting to be confirmed. And then, at the other extreme, there are supermassive black holes, giants millions or billions of times heavier than the sun. Their origins are still mysterious. Perhaps they grew from smaller black holes that fed for billions of years, or perhaps they were born differently, in ways we have yet to understand. Whatever their beginnings, they now sit at the centers of galaxies, including our own. So, black holes may be born in different ways. Through the collapse of stars, the merging of smaller black holes, the early chaos of the universe, or the quiet feeding and growing over eons. Each path different, and yet all leading to the same strange destination. A place where light cannot escape, a silent monster in the fabric of space. And so, we see that black holes are not accidents. They're natural outcomes of the universe's own rules. Where gravity becomes too strong, collapse is inevitable. And from collapse, darkness is born. Every black hole has a border, a line that separates what is still part of the universe from what is forever lost. This border is called the event horizon. The name itself is poetic. Event, horizon. It is a horizon beyond which no events can ever be seen, no signals can ever return. It is not a solid surface, not a wall of stone or light, but an invisible boundary, defined by gravity alone. Imagine standing on the shore of an endless ocean. You can watch the waves rolling in, you can hear them breaking, but far out over the horizon, the waves continue beyond your sight. The horizon is not a physical barrier. It is simply the limit of what you can see. The event horizon is like that. But instead of blocking our view, it blocks the very possibility of light and information escaping. Anything that crosses the event horizon is lost, not just hidden, but cut off from the rest of the universe forever. A spacecraft, a star, even a ray of light, once it drifts across, it can never return. The pull of gravity is absolute, the escape velocity, the speed needed to break free, becomes faster than light itself. And since nothing can outrun light, nothing can escape. But from the outside, the event horizon does not look like a wall. It appears as a perfect black sphere, a shadow in the starry sky. The shape is smooth, calm, featureless, a silent sphere of darkness. And yet, it marks the most dramatic boundary in the universe. To cross the event horizon would be to cross into silence. For the traveler who drifts too close, there is no sudden jolt, no crash into a surface. They would simply pass the point of no return, unaware in that moment that their fate has been sealed. Only later, as they drift inward, would they realize there's no way back. And so, the event horizon is both gentle and absolute. It does not strike or resist, it simply divides. The world outside and the world inside, two places forever separate, To understand the event horizon more deeply, let's imagine falling toward one. You are in a spaceship, drifting toward a black hole. From your perspective, as you approach, nothing unusual seems to happen at first. The black circle in the sky grows larger, surrounded by a bright halo of light bent around it. The event horizon itself is invisible, but you know it is there, waiting. If you cross the horizon, you would not notice anything sudden. No flash, no wall, no sound. But you would know, if you understood the physics, that in that moment you had passed into a place where escape was no longer possible. Now imagine a friend watching you from far away, safe outside the pull of the black hole. To them, your approach looks very different. As you near the horizon, they see your ship slow down, slower and slower. Your signals stretch out, fading. Your image grows dim, until to them you appear frozen at the very edge, never quite crossing over to the outside world. Time itself seems to stop at the horizon. This strange effect happens because of relativity. The immense gravity of the black hole bends time as well as space. From your perspective, you cross the horizon smoothly, but from theirs, you never quite vanish. Instead, you linger as a ghostly shadow, fading into silence. The event horizon is not only a boundary of space, it is a boundary of time, too. It divides what can still interact with the universe from what can never send a signal back. And in this way, it becomes more than a surface. It becomes a veil. There is also something haunting about this. For the traveler inside, time continues normally until it ends at the singularity. But for those outside, the traveler never seems to fall in. They remain suspended forever at the edge. This dual perspective is part of what makes black holes so strange and so beautiful. The event horizon is not simply a scientific concept. It is also a symbol. It represents a limit, the ultimate line beyond which knowledge is cut off. For scientists, this is both frustrating and inspiring. Everything that happens inside the event horizon is hidden. No light, no particle, no signal can escape to tell us what occurs within. We can only guess, only theorize, but we cannot know. And so, the horizon becomes a curtain drawn by nature, a place where our understanding falters. Yet, from the outside, we can still see its effects. We see stars whipping around unseen centers. We see gas swirling and glowing in brilliant disks just outside the horizon. We see jets of energy streaming from near the edge. The horizon may hide what is within, but it does not stop the black hole from shaping the world around it. In a way, the event horizon is the ultimate mystery. It says to us softly, "You may look this far, but no further." And yet, our curiosity lingers at the edge, always asking what lies beyond. There's also a dreamlike quality to this idea, that somewhere in the universe, there are places where time and space fold so deeply that they cut themselves off from the rest of reality. Places where the rules change, where silence reigns, where the universe itself keeps its secrets hidden. And so, the event horizon is not only a physical boundary, it is a boundary of imagination, of wonder, of what we can and cannot know. As you lie back tonight, drifting toward rest, you can imagine standing at such a horizon. The stars behind you, the silent darkness before you, a place of endings, but also of beginnings. The event horizon, quiet, invisible, eternal. At the very center of every black hole lies the singularity. It is the hidden heart, the core of gravity's silence. And though we speak of it with words, the truth is we do not fully understand what it is. The singularity is the place where the black hole's mass is thought to be concentrated into a single point, a point with no size, no surface, no width, and yet infinite density. It is where gravity grows without limit, where the pull is beyond measure. And here, our laws of physics, the rules that describe stars and galaxies, atoms and light, break down completely. To imagine it, let us begin softly with something simple. Take a mountain, tall, broad, heavy with stone. Now imagine compressing it, folding it inward, pressing it tighter and tighter until it fits into the size of a pebble. Now press it further until it fits into the head of a pin. And then imagine pressing again until there is no space left at all, until it shrinks beyond measure. That is what a singularity suggests: mass, press into nothing. It is not a place we can see. It is hidden, cloaked by the event horizon. And so, it exists more as a whisper in our equations than as an image in our minds. Einstein's theory of general relativity predicts it, but also cannot explain it. At the singularity, the fabric of space and time curves infinitely, and our mathematics collapse into infinities that have no meaning. It is as though nature has written here, the rules stop. The singularity is a boundary not only of space, but of knowledge, and yet, though we cannot see it, we feel its presence, for it is the singularity that anchors the black hole. It is the reason the horizon forms, the reason light cannot escape, the reason time bends so strangely, though invisible, though unknowable. It is the silent core around which all else turns. Scientists have long debated the nature of singularities. Are they truly points of infinite density, where the universe breaks itself? Or are they something different, something we cannot yet imagine, hidden beyond our current understanding? General relativity, the great theory of gravity, tells us that if a massive star collapses and nothing halts the collapse, all the mass must fall inward to a point. That point is the singularity. But general relativity does not speak the language of the very small, of atoms and quantum fields. At the scale of the singularity, we believe quantum mechanics must also play a role. Yet, when we try to combine the two, relativity and quantum theory, the mathematics unravel, contradictions appear, infinities spread across the page. This is why physicists say the singularity is not just a place. It is a puzzle. It is a riddle written into the heart of black holes, the challenge that tells us our current theories are not enough. Some scientists imagine that at the core, matter does not truly shrink to a point, but rather forms something exotic, something new, perhaps a sphere of quantum foam, where the smooth fabric of space-time becomes frothy and chaotic, perhaps a ring or a loop described by theories like string theory, or perhaps something stranger still, a place where time itself folds back on itself, where beginnings and endings blur. We do not know, and that not knowing is part of the mystery. Consider, for a moment, how many times in history humanity has stood at the edge of knowledge. We once thought Earth was the center of the universe, until telescopes revealed the stars moving differently. We once thought atoms were indivisible, until we found their hidden parts. And now, we stand at the edge again, looking toward the singularity, knowing it exists, but not knowing what it truly is. The singularity is, in this way, both frightening and comforting. Frightening, because it defies our understanding. Comforting, because it shows us there is still so much left to discover. There is also something deeply poetic about the singularity. At the heart of silence, at the center of darkness, lies a place that may hold secrets about the beginning of a universe itself. Some scientists have wondered, Could the Big Bang itself have been a kind of singularity? A point of infinite density, for which all space and time unfolded? If so, then singularities are not only ends, but also beginnings. They may mark both the collapse of stars and the birth of universes. To dream of the singularity is to dream of extremes, a place where time stops, where space folds, and where cause and effect may lose their meaning. It is a place that exists beyond sight, beyond sound, beyond thought, and yet its effects ripple outward, shaping galaxies, shaping time, shaping even us here on Earth. As you imagine it now, let your thoughts drift to that hidden center, a point beyond light, beyond escape, not violent, not roaring, but silent, still, like the calmest place in the deepest ocean, a point where all motion ceases. The singularity is the universe's secret, held quietly, beyond reach. And so, when we ask, what is the singularity? The only honest answer we can give is, we do not yet know. It is a reminder that in a universe of stars and galaxies, of light and energy, there are still places where wonder lives, still questions unanswered, still mysteries unbroken. And perhaps, in that silence, there is a kind of peace, that not all things must be known. Some can remain mysteries, gentle, dark, eternal. Not all black holes are the same. Some are small by cosmic standards. Others are unimaginably vast. To understand them, let's begin with the most common type, the stellar black hole. Stellar black holes are born from the collapse of massive stars. As we explored earlier, when a star much heavier than our sun runs out of fuel, its core collapses and a black hole may form. These black holes usually have a mass between a few times the sun's weight, up to perhaps a few dozen times. Imagine, for a moment, compressing something as massive as our sun into a sphere only about 30 kilometers wide. That is the size of a typical stellar black hole. To us, 30 kilometers may be the distance between two towns, a road trip, a short journey. But here, in that tiny space, the mass of an entire star is locked away. Its gravity is so intense, its pull so absolute, that light itself cannot escape. Stellar black holes are scattered across galaxies, often hiding in binary star systems. A visible star may circle an invisible partner. From the way the star wobbles, the way its light shifts, we can detect the unseen presence of a black hole nearby. Some stellar black holes feed quietly, sipping matter from a companion star. Others grow violent, tearing streams of gas that swirl into blazing accretion disks, shining brightly in X-rays. Though invisible themselves, they reveal their presence to the chaos they create around them. They are the smallest of the confirmed black holes, yet they are still powerful. And in their smallness, they show us that even the quiet remnants of stars can hold incredible mysteries. At the other extreme of size are the giant of the universe, the supermassive black holes. While stellar black holes may be a few times the sun's mass, supermassive black holes are millions, even billions of times heavier. They do not form from single stars, for no star is large enough to collapse into something so vast. Instead, their origins remain uncertain. Perhaps they grew slowly, feeding for billions of years, or perhaps they were born in the earliest moments of the universe. What we do know is that nearly every galaxy has one at its center. Our own Milky Way has Sagittarius A*, weighing about 4 million suns. And some galaxies hold even larger monsters, like the one in the galaxy M87, whose black hole weighs 6.5 billion suns. This is the black hole we first imaged in 2019. capturing its glowing halo of light in its dark, perfect shadow. Supermassive black holes are like anchors, holding galaxies together. Stars whir around them. Dust and gas spiral inward, and their influence reaches across vast distances. Without them, galaxies might not form as we know them. And yet, despite their enormous size, they are calm compared to smaller black holes. Their event horizons stretch wide, but for a traveler falling toward one, the tides of gravity may be gentler. Paradoxically, falling into a supermassive black hole might be less violent at first than falling into a small one, because the gradient of gravity, the difference between your head and your feet, would be less extreme at the horizon. Still, inside, the singularity waits. And despite their vastness, their hearts remain as mysterious as those of their smaller cousins. These giants remind us that black holes are not only endings, but also cosmic architects. They shape galaxies. They feed jets of energy. They guide the structure of the universe itself. Between the smallest stellar black holes and the largest supermassive ones lies a mystery. Astronomers have long wondered if there are intermediate black holes, those with masses of hundreds or thousands of suns. Evidence for them is faint, but growing in clusters of stars. We sometimes see hints of something heavier than a stellar black hole, but lighter than a supermassive one. Perhaps these are stepping stones, black holes that grew by merging, but never reached galactic scales. Then there is another possibility, whispered from the earliest days of the cosmos: primordial black holes. These would not come from stars at all, but from the birth of the universe itself. Moments after the Big Bang, matter was not evenly spread in some places. It clumped more tightly. If those clumps were dense enough, they may have collapsed into tiny black holes. Some could be as small as mountains, others no larger than atoms. If they exist, they could still drift unseen through space today. Perhaps some may even make up a portion of the mysterious dark matter that fills the cosmos. We have not yet found them, but the idea lingers, haunting and beautiful, that some black holes may predate the first stars, relics of the universe's beginning. So, black holes come in many sizes, from stellar remnants, small but fierce, to supermassive giants, calm but powerful, to the hidden middle ground of intermediate black holes, and perhaps to the ancient whispers of primordial ones. Each type different, and yet all share the same essence. A place where gravity rules absolutely. A place where light cannot return. A place where silence is written into the fabric of space. As you think of them now, let your mind drift across scales, from the size of a city to the heart of a galaxy. Black holes stretch across the cosmos in all sizes, all forms, each one a reminder that the universe creates wonders at every scale. Time is something we all know deeply. We count it in seconds, minutes, hours. We feel in the rhythm of day and night, in the seasons, in the stories of our lives. Yet near a black hole, time behaves in ways that feel almost like dreams. According to Einstein's theory of relativity, time and space are not separate. They are woven together into a single fabric, space-time. Massive objects bend as fabric, and black holes, being the heaviest of them all, bend into extremes. Imagine standing far from a black hole, watching a clock that drifts closer to the event horizon. To you, the clock seems to tick more slowly. Each second stretches out. 1 minute becomes longer than a minute should be, and as the clock nears the horizon, its ticking almost freezes from your view. Time itself seems to stop at the edge. But for the clock, for the traveler carrying it, nothing unusual seems to happen. They continue to feel time normally. Their heartbeat steady, their thoughts flowing second by second. This strange mismatch is called time dilation. It means that time is relative, depending on where you are and how strong gravity pulls upon you. So near a black hole, time for an observer inside flows normally, but to someone far away, it looks as though that person has been slowed, stretched, perhaps frozen forever on the edge. This is no trick of perception. It is real. Black holes truly change the way time moves. Think of it like walking on a soft, stretchy fabric. When you stand on one spot, you sink deeper, and time beneath you moves differently than it does for someone higher on the cloth. Black holes sink so deep into space-time that the difference becomes extraordinary. And so, black holes are not only silent monsters of space, they're also strange sculptors of time, reminding us that what we call now may not be the same for someone else in a different place, under a different pull of gravity. Now let us imagine a traveler slowly drifting toward a black hole. To them, the fall feels natural. They continue to breathe, to think, their own clock ticking at its steady pace. But from a view of someone far away, on a distant planet or ship, the traveler slows down. Their motions become slower. Their light grows redder. Their signals stretch longer and longer until, as they approach the horizon, they seem to freeze in place. What happens next is a matter of perspective. For the outside observer, the traveler never quite crosses the horizon. They remain suspended at the edge, their image fading, their signals weakening, forever hovering on the brink. But for the traveler themselves, they cross the horizon easily, without pause. And as they move inside, time continues normally for them. But the universe outside races ahead. If they could somehow look back, they would see distant stars whirl and change rapidly. Entire centuries might pass in moments. Civilizations could rise and fall, while to them only a few minutes had gone by. In this sense, falling into a black hole could be like falling into the future. You would experience your own life in normal rhythm, but the outside universe would rush forward, faster and faster, leaving you behind. This idea is not just poetic. It is grounded in real mathematics of relativity, and it reminds us that black holes are not just prisons of matter. They're also doorways into strange experiences of time. One famous example comes from the movie Interstellar. On a planet near a black hole, 1 hour equals 7 years for those far away. While dramatized, this concept was based on real physics. The stronger the gravity, the more time dilates. And near a black hole, the effect is at its most extreme. So, black holes do not only consume stars and light, they consume the very flow of time, turning seconds into eternities, and eternities into moments. Now we reach the most mysterious part. What happens to time inside a black hole? Here, our equations strain, our theories falter. Inside the event horizon, space and time may trade places. The pull of gravity is no longer something you can resist. It becomes as inevitable as the flow of time itself. Just as you cannot stop moving forward in time, inside a black hole you cannot stop moving inward toward the singularity. This means that, in a sense, the singularity is not just a place in space. It is a place in time. For the traveler, reaching it is as unavoidable as tomorrow. And yet, what happens at that final point remains unknown. Our physics breaks down there. Perhaps the singularity is truly infinite density, an end of space and time. Or perhaps new laws of nature emerge there, still hidden from us, Some theories suggest that time could continue in a new way beyond the singularity, that black holes might connect to other universes, that what seems like an ending to us could be a beginning somewhere else. We do not yet know, and maybe we never will, for the event horizon hides these answers forever from our view. But in dreaming of them, we stretch our minds, just as black holes stretch time itself. We are reminded that the universe is stranger than we can imagine, that time, which feels so steady in our daily lives, is flexible, malleable, and deeply tied to gravity. So tonight, as you drift toward sleep, think of time flowing gently, like a river, and imagine a black hole where that river is pulled, stretched, twisted into patterns beyond comprehension, where seconds and centuries dance together, where falling inward could mean leaping into the far future, and where mystery remains at the deepest heart of space. When we think of black holes, we imagine emptiness, silence, the place where light itself is swallowed. And yet, around many black holes, the very opposite is true. They shine with the brightest lights in the universe, glowing so intensely that we can see them across billions of light years. This light does not come from the black hole itself, but from the matter spiraling into it. Gas, dust, and sometimes even entire stars are pulled toward the invisible core, but instead of falling straight in, they begin to circle. Much like water spiraling down a drain, they form a flat, spinning structure. This is the accretion disk. The word accretion means gathering or growing by layers. An accretion disk is exactly that, matter gathered and flattened into a luminous, rotating disk. Friction between particles heats the gas to extraordinary temperatures, so hot, in fact, that it begins to glow in visible light, ultraviolet, and even X-rays. From Earth, we cannot see the black hole directly, but we can detect the blaze of its accretion disk. It is like hearing the roar of a waterfall without seeing the drop itself. The disk tells us where the invisible monster lies and how powerfully it feeds. Accretion disks are not always steady. Sometimes they flare with sudden brightness, when a black hole tears apart a passing star. Other times they flicker, dim, and build again as streams of gas shift and collide. They are living, dynamic structures, where the quiet gravity of a black hole becomes visible as light. And in their beauty, they reveal a paradox, that the darkest object in the cosmos can also be surrounded by the brightest beacons we have ever seen. Let us now move closer and imagine drifting above an accretion disk. The gas whirls at nearly the speed of light, each particle colliding with others, releasing energy. Temperatures soar into millions of degrees. Atoms are stripped apart into plasma, a storm of electrons and nuclei glowing fiercely. At these scales, the disk becomes one of the most efficient engines in the universe. For every bit of matter consumed, it can release more energy than nuclear fusion itself, the very process that powers stars. This is why quasars, which are young galaxies with ravenous black holes at their centers, can outshine all the stars of their host galaxies combined. Imagine a lighthouse in the deep night, its beam cutting across the sea. Now expand that image to cosmic scales. A quasar's accretion disk can be seen billions of light years away, shining across nearly half the observable universe. And yet, if we were close, the view would not be steady light. It would be violent, dynamic, shifting constantly. Flares of energy, bursts of radiation, jets of plasma streaming outward at near light speed, all born from the simple act of matter falling, spiraling, colliding under the pull of gravity. The inner edge of the disk is marked by the innermost stable orbit. Beyond this point, matter cannot maintain a steady circle. It plunges inward, across the event horizon, never to return. This region defines a boundary between the luminous disk and the silent core. It is like standing at the rim of a great waterfall, where the smooth river suddenly breaks into a drop, one side glowing, alive with energy, the other a silence that nothing can escape. And so, accretion disks remind us of the delicate balance between chaos and order, between motion and stillness. They are both violent storms and graceful spirals, a paradox of beauty born at the edge of destruction. Accretion disks do more than glow. They tell us stories. Astronomers cannot see black holes directly, but by studying disks, we learn their secrets. The flickers of light reveal the black hole's spin, its appetite, its hidden weight. Each variation is like a heartbeat, whispering the rhythm of the invisible core. In some systems, black holes tear stars apart, creating tidal disruption events. As the star stretches and breaks, its gas spreads into a new disk. For weeks, months, or even years, the black hole shines with the dying light of what it consumed. A final flare of brightness before silence resumes. In other systems, the disks give birth to jets, powerful streams of plasma that erupt from the poles of the black hole, shooting out across galaxies. These jets can stretch for thousands of light years, sculpting the space around them. It is still a mystery how black holes launch them, but they remind us that even in consuming, black holes also create. They shape galaxies, fuel quasars, and stir the cosmos with their energy. Accretion disks are also bridges of imagination. They help us picture the unseeable. If a black hole is a silent stage, the accretion disk is a performance upon it, blazing with drama and beauty. So, when you close your eyes tonight, imagine one of these disks, a glowing spiral, turning endlessly in the dark. Each particle a tiny star of its own, heated by friction, rushing faster than we can imagine. Together, forming a cosmic whirlpool of light around an invisible heart. And remember that in the deepest silence of space, there are places where destruction gives birth to beauty, where the invisible becomes visible, and where the darkest mysteries of the universe shine brightest of all. When we call black holes silent monsters, we are not speaking in metaphor alone. They are truly silent. Unlike stars that shine or supernovae that explode with thunderous light, black holes emit no sound, no visible glow of their own. They wait, hidden in the darkness, until something drifts too close. And yet, their silence does not mean they are weak. It is the silence of certainty, the calmness of an unstoppable pull. Wherever they are, they dominate their surroundings. Stars orbit them. Gas clouds fall toward them. Galaxies bend under their influence. Imagine, for a moment, a stellar black hole drifting alone in interstellar space. No companion star, no gas to feed on. It would be invisible, a wandering shadow. And unless it passed directly in front of background starlight, bending it through gravitational lensing, we would never know it was there. This quietness makes them both terrifying and beautiful. Terrifying, because they could drift unseen, hidden predators in the darkness. Beautiful, because in their silence they remind us of the unseen power woven into the universe. And so, black holes are monsters unlike any other. Not roaring, not raging, but waiting, patient, invisible, pulling all who come too close, without effort, without sound. To call them monsters is to recognize their hunger. Black holes feed not with mouths, but with gravity. Whatever crosses a horizon, gas, dust, stars, even light itself, becomes part of them erased from the outside universe. And yet, there is no violence at the horizon itself. Crossing it, you would notice nothing unusual in that moment. The silence continues, the pull steady. The monster swallows without a ripple. Only outside, in the region of the accretion disk, do we see drama and fire. The disk flares, the jets burst, the energy roars into space. But the black hole itself remains silent, indifferent to the spectacle around it. This silence is part of their nature. It is not the silence of absence, but the silence of finality. Inside the horizon, no signal escapes, no light, no sound, no story. It is as if the black hole whispers, "All that enters belongs to me, forever." Even time itself is silenced inside. The future collapses inward. Paths end at the singularity, and nothing of what happens there can return to us. We stand outside wondering, imagining, but never hearing an answer. This is why they are called monsters, because they consume not only matter, but also information, light and sound. They consume the possibility of knowing what happens beyond their veil. Yet in this monstrous silence, there is also mystery. For perhaps what we call destruction may be something else entirely. Perhaps black holes are not only ends, but transformations. Silent not because they destroy, but because they conceal. Let us now soften our view of them. For though they are often described as monsters, there is also elegance in their silence. Unlike the chaos of exploding stars, black holes are steady. Their pull is predictable, their orbits precise. They shape galaxies, hold stars in motion, and even create the conditions for life to exist in the wider cosmos. Without the monsters, the dance of the universe would not be the same. Think of Sagittarius A*, the supermassive black hole at the heart of our galaxy. For millions of years, it has sat in silence. It does not roar, it does not flare often, yet it anchors the Milky Way, giving structure to the spiral arms where our sun and Earth circle. Without it, our galaxy might never have formed as it did. So perhaps we should see them not as monsters of terror, but as silent guardians, shaping the cosmos in ways we are only beginning to understand. Even their hunger has purpose. By consuming matter, they fuel quasars, light up galaxies, and drive winds that spread elements far and wide. From their silence comes creation, balance, and beauty. And so, as you rest tonight, imagine black holes not only as destroyers, but also as mysterious caretakers of the cosmos. Silent, yes, monstrous in power, but also necessary, elegant, and deeply woven into the fabric of existence. In their silence, we hear the calm rhythm of the universe. In their darkness, we glimpse the hidden balance that holds galaxies together. And in their monstrous pull, we sense the mystery that still invites us to dream, to wonder, and to search for answers among the stars. When we gaze at the night sky, we see a scattering of stars, a quiet band of light stretching across the darkness. That band, the Milky Way, is our home galaxy, and deep within its center lies something hidden, something silent, a supermassive black hole called Sagittarius A*. For many years, astronomers wondered if black holes and galaxies were connected. Now the evidence is clear. Nearly every galaxy we have studied seems to hold a supermassive black hole at its center. From small, dim galaxies to giant elliptical ones, the story repeats itself. A core of darkness at the heart of shining starlight. These black holes are not intruders. They are part of the galaxy's very design. Stars orbit them, dust gathers around them, and sometimes entire streams of matter spiral inward toward them. They are like the anchor stones of galaxies, holding everything together. Our own Sagittarius A** is relatively quiet. It does not shine with the fierce light of a quasar, though sometimes it flares briefly as gas drifts close. But it still holds sway over millions of stars in the galactic core. Its pull ensures that the Milky Way remains bound in its spiral arms, orbiting patiently, century after century. So, as you look up tonight, remember, the galaxy above you is not just a scattering of stars. It is a vast, organized dance, circling silently around a black hole at its heart. Black holes do more than sit quietly at galactic centers. At times, they awaken, feeding hungrily, blazing so brightly that they reshape the galaxies around them. When gas and dust fall into a supermassive black hole, they do not vanish quietly. They form immense accretion disks, glowing hotter than any star. And often, black holes launch jets of plasma, reaching across thousands, sometimes millions of light years. These jets can push gas out of galaxies, stir star-forming clouds, and shape the very growth of galaxies themselves. This is why quasars, which are galaxies with fiercely feeding black holes, are so astonishing. They can outshine all the stars in their galaxies combined. For a time, the galaxy's identity becomes defined not by its stars, but by the light of its core. Yet, even in this violence, there is balance. When black holes consume too much gas, their outbursts can blow material away, halting new star formation. In this way, they regulate galaxies, preventing them from growing endlessly. They set limits, boundaries, rhythms to the life of stars within. And so, galaxies and their black holes are partners. One feeds the other, one regulates the other. Without supermassive black holes, galaxies might collapse chaotically or grow without balance. But with them, the structures we see today, the graceful spirals, the giant clusters, take their elegant forms. Imagine a gardener tending a vast cosmic field, at times trimming, at times nurturing, shaping the growth of stars and gas. That is what supermassive black holes do for galaxies silently, invisibly, over billions of years. When we look farther into the large-scale structure of the universe, we find galaxies arranged in clusters and filaments, stretching like a cosmic web. At the heart of many of these galaxies, black holes sit, silent engines of gravity and light. The relationship between galaxies and black holes is so close that astronomers have found a remarkable connection. The mass of a galaxy's central black hole is linked to the size of its galactic bulge, the dense region of stars near the core. This means as galaxies grow, so do their black holes. And as black holes grow, they influence the galaxies in return. It is a cosmic partnership, stretching across time and space. The largest structures in the universe are shaped, in part, by the smallest regions, event horizons, no larger than the span of a solar system. Think of it, a galaxy of billions of stars, shaped by a single point of darkness at its center. The contrast is breathtaking, and yet it is true. This interdependence hints at something deeper. Perhaps black holes and galaxies were born together in the early universe. Perhaps their destinies have always been linked, each one sculpting the other across billions of years. So tonight, as you rest, picture a galaxy glowing faintly in the night, and at its center, a silent core, a black hole, holding it steady. Without it, the galaxy might drift apart. With it, the galaxy endures beautiful and balanced. The next time you see the Milky Way stretching across the sky, remember that you are looking at a home shaped by a black hole, a silent monster, yes, but also a guardian, anchoring the spiral arms, keeping the stars in their grand, unending dance. Even after decades of study, black holes remain wrapped in mystery. We understand their gravity, their horizons, their disks, and their jets. And yet, at their very heart, at the singularity itself, our knowledge falters. What truly lies beyond the event horizon? Is it simply an end, an infinite point where matter and time collapse? Or could there be something more? Some theories suggest that singularities may not be final at all, that they could be doorways into other regions of space and time, perhaps even into entirely new universes. This idea, called a wormhole, imagines black holes connected to white holes, where matter is not destroyed, but released elsewhere. We do not yet know if such things exist, but the possibility lingers as a dream just beyond reach. Then there is the question of information. When something falls into a black hole, is its story erased forever? Or is the information somehow preserved, hidden in the quantum fabric of the horizon? This puzzle, called the information paradox, remains one of the greatest challenges of physics. It is as if the universe is telling us, here, you may come no further unless you learn something new. And so, black holes are not only cosmic monsters, they are also cosmic teachers, showing us the limits of our understanding and inviting us to imagine possibilities beyond what we know. Now, let us drift deeper into imagination, for while science is grounded in evidence, dreams of what black holes might be open doorways to wonder. Some scientists suggest that black holes could connect different regions of space, that stepping through one could mean emerging somewhere else entirely, far across the galaxy, or perhaps in another universe altogether. These are the ideas of wormholes, bridges in space-time. For now, they are mathematical possibilities, beautiful in theory, though unproven in reality. Others wonder if black holes may play a role in the birth of new universes, that perhaps, when a black hole collapses deeply enough, its core becomes a seed of another cosmos. Inside, a new Big Bang, hidden from us, branching out like a tree of realities. And then there is the mystery of Hawking radiation, the idea that black holes are not eternal, that they slowly leak energy, particle by particle, until one day they vanish. If true, this means even the most massive black holes will fade away, leaving behind not monsters, but silence and emptiness. Perhaps billions of years from now, when galaxies have grown quiet and stars have burned out, the last light of the universe will come not from stars, but from the slow fading glow of black holes, their final whisper before disappearing into nothing. These possibilities, wormholes, baby universes' evaporation, remind us that black holes are not just cosmic endings. They may also be beginnings, bridges, and transformations, linking the known universe with realms beyond imagination. And so we arrive here, at the end of our quiet journey into black holes. We have seen how they form, how they grow, how they shape galaxies and bend time, how they glow with disks of light, yet remain silent at their hearts. And now, we linger with the greatest mysteries still unsolved. Will we ever know what lies beyond the horizon? Will we ever learn the fate of information, or the truth of Hawking's fading radiation? Perhaps one day, through new physics, new telescopes, new dreams, we will understand. But perhaps, too, black holes will always keep some secrets, reminding us that mystery itself has value, that wonder is part of what keeps us looking upward at night. As you drift towards sleep now, imagine the universe as a vast ocean of stars, and scattered across it the silent monsters we have spoken tonight. Not enemies, not terrors, but guardians of balance, anchors of galaxies, and keepers of mysteries. They are the dark hearts of the cosmos, and in their silence, they whisper possibilities yet to be discovered. So, close your eyes gently, let your breath slow, and feel the calm of knowing that the universe is vast, mysterious, and filled with wonders beyond measure. From my heart to yours, may you rest peacefully. May your dreams drift like starlight, and may the silence of black holes bring you comfort. For in their quiet there is beauty, and in their mystery there is endless discovery. Good night and goodbye until we journey again into the stars.